Mole concept. What is a mole? It is represented by N and it is mass of a matter divided by its atomic mass or molecular mass. This is the simple equation for mole. Mole is the ratio of mass of a matter, whether it is an element or it is a compound. If it is an element, it is divided by atomic mass, and if it is a compound, it is divided by its molecular mass. So, in other words, we can say N equal to mass of an element divided by its atomic mass. It will be for the elements like iron, sodium, potassium, calcium, chlorine, oxygen, etc. In atomic form, mass of an element taken divided by its atomic mass, this ratio represents mole of that element. Since we know iron, its atomic mass is 56, sodium, its atomic mass is 23. If we put 56 gram of iron, then what it means? N for iron, moles of iron in 56 gram will be equal to 1 mole. So what is a mole? Mole for an element is the mass of an element taken divided by its atomic mass. That is, ratio of the mass of an element taken with the atomic mass of that element represents moles of that element. If we take 56 gram of iron, then it contains 1 mole of iron. Like it, since sodium has 23 atomic mass, if we take 23 gram of sodium, then divided by atomic mass 23, it will represent 1 mole of sodium. So sodium 1 mole has 23 gram mass. This is for the element equation 1. If we take equation for molecules for a compound, since we know a compound has simplest form, a molecule, here N mass of a compound taken divided by molecular mass. Molecular mass. This is equation second. If the moles is related with the compound, then the mass of the compound taken, it is the ratio of the mass of the compound with its molecular mass represents moles of that compound present in the given mass. For example, we know water, H2O. Since 2 hydrogen and 1 oxygen, hydrogen has atomic mass 1 and oxygen has 16. Putting this value here, 2 into 1 plus 16 means 18. 18 is the molecular mass of hydrogen. If we take 18 gram of hydrogen, then it will contain its 1 mole. So what is a mole for water? For water, if we take 18 gram mass of water, it contains 1 mole because molecular mass of water is 18. Like it for other compounds like ammonia, NH3. We know nitrogen atomic mass 14, hydrogen atomic mass 1. So putting value here, 14 plus 3 hydrogen equal to 17. If we take 17 gram of ammonia, then it contains 1 mole of ammonia. So what is a mole? Amount of a compound or of a matter taken divided by its molecular mass. If it is a compound divided by the molecular mass represents mole of that compound. Next is with respect to number of particles. If we consider moles regarding number of particles, so we will discuss about the Avogadro number. Avogadro number. What is this Avogadro number? It is represented by Na, Avogadro number, and its value is 6.022 into 10 to the power 23 atoms or molecules per mole. Atoms or molecules present in 1 mole of a matter has value 6.022 into 10 to the power 23 at NTP, normal temperature and pressure. 1 mole of matter contains this number of particles, that may be atoms or molecules. It is called Avogadro number. How it obtained? So we know from mass spectrometer, the experimental value obtained for C12 isotope of carbon, mass of one atom. Mass of one atom of C12 isotope of carbon that was obtained on the basis of mass spectrometer. It was 1.99 into 10 to the power minus 23 gram per atom. One atom has the mass 1.99 into 10 to the power minus 23. It was experimental data obtained on the basis of mass spectrometer. Since we know C12 isotope has atomic mass unit 12, AMU atomic mass unit. Therefore, in gram we can say 1 mole contains 12 gram. 12 gram is the value of 1 mole of C12. So, in first one atom has the mass 1.99 into 10 to the power minus 23 gram per atom. And what is the mass of 1 mole of C12 isotope? This is 12 gram. So, we can note down number of particles. Now, number of particles per mole will be 12 gram per mole. This is mass of C12 isotope for 1 mole divided by 1.99 into 10 to the power minus 23 gram per atom. This is the mass of one atom. When overall mass for 1 mole will be divided by mass of one atom, total number of particles will be obtained. That value will be 6. Now after calculation, you will get this value 6.022 into 10 to the power 23. Number of atom or molecules at NTP. This value is Na, Avogadro number. So Avogadro number value is the number of particles present in 1 mole of a matter, and its value is fixed 6.022 into 10 to the power 23. So, with respect to number of particles, the equation for mole n will be nx divided by Na. This is the third equation of mole. The ratio of number of particles of a matter with Avogadro number represents moles of that matter present in it. This Nx is number of particles given, and this value Avogadro number is fixed. This value will be fixed because it is 6.022 into 10 to the power 23. So next equation for mole concept will be mole equal to nx divided by Na, where nx will be the number of particles given. That value will vary in different equations in different experiments, but Na will be a fixed value and it will be 6.022 into 10 to the power 23. After number of particles, we will discuss about molar volume related to mole concept. What is molar volume? As per Avogadro, molar volume is a value Vm represented by Vm. This is molar volume. Molar volume is a value that 1 mole of a matter occupies. The space occupied by 1 mole of a matter is called its molar volume at NTP, normal temperature and pressure. And what is this value? This is 22.4 liters. This is also a fixed value. 1 mole of any matter occupy 22.4 liter at NTP. We can find out the next equation. Therefore, mole with respect to volume Vx divided by Vm. This Vx is volume occupied at any condition, and Vm is the volume occupied at NTP. This is molar volume. So this will be the fourth equation for mole concept. Here, how this molar volume has been obtained, so we will discuss for it from gas equation, molecular theory of gases, and Pv equal to nRT. From kinetic molecular theory of gases, Pv equal to nRT. Therefore, V equal to nRT divided by P. Since at NTP, normal temperature and pressure, temperature T equal to 273 Kelvin, pressure P 1 atm, N for 1 mole, and R is the gas constant 0.0821 liter atmosphere per Kelvin per mole. When we will put this value T 273, pressure 1 atm, moles 1 mole, and R 0.0821 liter atmosphere per Kelvin per mole. When put this value here in this equation, you will get Vm 22.4 liter. So this is the molar volume, and ultimately the last equation of mole concept has obtained, and it is related with the volume occupied. So mole equal to Vx divided by Vm. Here Vx is the volume occupied at given condition, while Vm is the molar volume occupied at NTP. So the flow sheet for the mole concept we can make like number of moles will be related to the volume, mass of element, mass of a compound, and number of particles of matter. So in other words, we can note down the mole as mole with respect to the elements. So mass of elements. If the question is related with the elements, then mass of element divided by atomic mass. If a compound is given, then mass of compound given divided by its molecular mass. If it is related with volume, then Vx divided by Vm molar volume, and if it is related with number of particles, then Nx divided by Na. So mole concept has the four equations that are interrelated to each other. We can find out the volume occupied on the basis of number of particles. We can find out the mass of compound on the basis of volume occupied. These are interrelated to each other. So what is the mole? Mole is the ratio of mass of an element with the atomic mass of that element. It is ratio of mass of a compound with the molecular mass of a compound. It is the ratio of volume occupied by a gas with the molar volume of the gas, and number of particles of a matter with the ratio with the Avogadro number. So this is all about for the mole concepts, and we can solve the numerical analysis on the basis of these equations. Thank you.